we have a riddle. I am thinking of two numbers that add up to 5.678. The difference between them is 9.876. What are the two numbers? So first you have to name any pair of numbers whose sum is 5.678. So someone at table 7, can you tell me what you came up with? All right, class, does that add up to 5.678? Could you have done anything different and it still be like an acceptable answer? Okay, you could do whatever that is. I don't know what it is, but 2.839 plus 2.839. As long as it adds up to this, then great job. That's all you need to do is take any pair of numbers that add up to 5.678. So then table 8, can you tell me any pair of numbers whose difference is 9.876? So any pair of numbers that when I subtract them, I get 9.876. You have limited options. Any pair of numbers that when you subtract them, you get 9.8. Well, like just any two numbers. Bella M, you got something? Just any two numbers. We can wait. We can wait for them to come up with something. Play around with numbers until you get something that when you subtract them, it's 9.876.
$19.752.
Okay, 19.752. And what do I need to subtract from it to get this?
9.826.
Okay. Class. Or maybe I'll verify it because I have a calculator on me. So 19.752 minus 9.876 does give me 9.876. Good job. Could you have taken other numbers? Yes. So just whatever you guys came up with, first ones I'm using. Now it says the riddle can be represented with two equations. You needed to write the equation. So what do equations have to have? Equal signs, and it says we need two of them. Does that necessarily mean we have to use the numbers that you guys said for 1 and 2? Did anyone come up with the equations? All right, so this is a riddle. Like we don't actually know the answers. We know that there's tons of answers for numbers that add up to 5.678 and numbers that the difference is 9.876. But what the riddle is saying is that they're thinking of two numbers that do both. All right, do the numbers that we picked do both necessarily? Add up to this and subtract to this? All right, no. So making, and hopefully you recognize it, a system of equations can help us figure out what exactly those two numbers are. Because it's the same numbers in each situation. How do we label unknowns in math? With variables. So if I'm thinking of two numbers that add up to 5.678. All right, 5.678 is one of my totals. Remember, I told you to look for that first. How can I write that two numbers add up to 5.678, but I don't know what they are? Okay, good. What will the other equation be? Table 1. So we helped you out with the first one, kind of as a model. We show that two numbers add up to 5.678. How can I show that the same two numbers, when I subtract them, is 9.876? All right, and then what should go here? Okay, good. So what we just set up is a system of equations, and we use the same variables in each, and that can help us actually solve. Now, if you remember systems of equations, there was tons of methods that you could use to solve. It's up to you. What method do you guys want to use to solve today? Like elimination, you mean, like where we add or subtract them together? Okay. You are also allowed to use Desmos, so you can use that to check your answer. But if we're solving by elimination, and Kate said specifically by adding, am I able to do that? Will that eliminate one of the variables, class? Okay, great. It eliminates the y. So what's x plus x? 2x. What's y plus negative y? So that cancels. I don't need to write the plus 0. You could if you want to. And then now I need to add these together. 5.678 plus 9.876, and we get 15.554, right? Okay. So now we're solving for x. What's the opposite of multiplying by 2? Dividing, whatever you do on one side of the equal sign. So one of the numbers that will meet both constraints is going to be whatever that is divided by 2, 7.777. How can I figure out what the other number is? Plug it back into one of the original equations. It does not matter. So I think they're both equally as hard or easy, so I'll just plug it into the first one. And I'm plugging it in for the x. So when I plug it in, it'll look something like this: 7.777 plus y equals 5.678. And now we're isolating y. So how can I get rid of the number that's being added to the y? And whatever you do on one side. Okay. Great. Now I get y equals, let's see, negative 2.5. Are we rounding? Let's see, 5.678 minus 7.777 is negative 2.099. Maybe I just heard you wrong. All right, so those two numbers, and you can feel free to double check it if you want. When you add them together, you get 5.678. When you subtract them, x minus y, you do get 9.876. So questions, comments, concerns on that warm-up? All right, now you might be wondering why we are doing a system of equations when we have been focusing on inequalities. So let's just look at the goal for today for a second. Today, we're looking at situations where two constraints must be met simultaneously, specifically when they're inequalities. So those two things that we talked about in the warm up, where they have to add to a certain number and then subtract to a different number. When they have to be met simultaneously, there's usually only one answer if it's equation. For inequalities, there's usually like a range of combinations. So there's ones that are right, there's ones that are wrong. So we'll look at that today. You need to be able to write a system of inequalities based on a situation. Now, the difference with inequalities and equations is inequalities can only be solved by graphing. Okay, cannot solve them by elimination or substitution, only by graphing for linear inequalities. And then interpret what the solution means. So when it's two variables, usually you can write it as a coordinate, whatever the x is representing, and whatever the y is representing, you have to be able to say that on your constructed response and on your eliminating coefficient, and things like that. So questions on what we're doing today, the goal. Okay, so I'm recording right now. Feel free to watch the videos from the last year, or if you want to get ahead, they're all there for the week. Puzzle piece for this specific lesson is 24. But if you'd rather prioritize the study guides, maybe you're a bit more behind, then that would be a good idea. All right, worth more points, and they are closely aligned to the test. So those are available. And binder check is on Thursday. List is here of what I'm checking. And here's the schedule for all assessments and deadlines up until Thanksgiving break. Yes. So the binder check one? This one? Okay. Okay. They are also in school, but okay. Anyway, so let's move on to the next example. Something about a quilting project. If you want to follow along, it's on your paper. So to make a quilt, a quilter is buying fabric in two colors, light and dark. He needs at least 9.5 yards of fabric in total. The light color costs $9 a yard. The dark color costs $13 a yard. The quilter can spend up to $110 on fabric. Here are two graphs that represent the two constraints. You need to write an inequality to represent the length constraint. And it specifies what it wants X to be and what it wants Y to be. So make sure you follow that. And then select all pairs that satisfy the length constraint. Then you need to write an inequality to represent the cost constraint. So great practice for what you'll have to do on the test. You've already done it before for equations, but this is inequalities now. So look for those signal words that tell you what symbol you need to use. I'll let you work out 1 through 4 in your table groups. So be prepared. I'll assign a reporter after 5 minutes. I think that's plenty of time, 5 minutes. So first you had to write an inequality to represent the length constraint. What is the length constraint? Okay, now is that describing the constraint on the length? Let's read the description again. He needs at least 9.5 yards of fabric in total. He can spend up to $110 on fabric. So does what you said describe our length? What does it describe? The cost constraint. So maybe let's move that down here for number 3. Now, is that right, class? Do you agree for the cost constraint that it should be this? Yeah. Okay, so the only thing I need to re-examine is the symbol. If you can spend up to 110, can you spend less than it? And can you spend exactly it? Okay, then great. So yeah, when we're talking about costs, like dollar amounts, keep them with your dollar amount. So your dollar amount total, you should have dollar amounts on the other side. So that looks good for our cost constraint. Table 3, can you tell us our length constraint? So yeah, he needs at least 9.5. So how can I represent that mathematically? So if that's like the constraint on the length, should I times it by something? So then maybe don't do that. Don't put an X next to it. But yeah, you should have 9.5 in it somewhere. Technically, you can write it on this side, but what should be next to your totals usually? An equal sign, except for now, does at least necessarily make it be an equal sign? It makes it an inequality, right? So what symbol should it be? Okay, class, would you agree with that? That it should be greater than or equal to 9.5?
I agree.
Okay, yeah, if you can need at least, you could have more. This over here would be whatever he actually does by. And then it can be exactly if it's at least, right? So that's a good symbol to use. What should go on the left of it? Table 3, do you have that? Or table 4, can you tell me what goes on the left of this? X plus Y. I think that is good. Because look at what X and Y are supposed to represent. It tells you in the number 1 description. It says, let X be the yards of light fabric, let Y be the yards of dark fabric. Adding them together, they just have to be greater or equal to 9.5. And usually, when you're making your system, one of them is really simple like that. Not all the time, but usually. So questions on the setup. Now for the next part, we need to select all pairs that satisfy the length constraint. And this is great practice for your test. So table 5, does 5.5 satisfy the length constraint? Yes or no? Okay, so 5, does this coordinate satisfy the length constraint? No, because what's 5 plus 5 class? And it, well, actually, it would satisfy it. So you could do it by plugging it in. 5 plus 5 is 10. Is that greater or equal to 9.5 class? Yes. Does anyone know how else we could see that that is satisfying it? Other than plugging it in. All right, what about these graphs? Which one would be for my length constraint? I'm gonna do that. Okay, A for the length constraint. See where 5 is. This is counting by 2, so 5 would be like in the middle here. And it was a solution, wasn't it? Anything that's on a solid line is a solution. So there you go. Table 6. Do any of these other coordinates satisfy the length constraint? All right, any others? 10.5. But not this one? Okay, class, would you agree with that? Yeah. Okay, I know 12 plus 10 for sure is greater than 9.5. Same here. Mental math, that's equal to 7. So no, that one doesn't satisfy it. But also you could check it visually, like here is 1210, 7.5, 3.5, looks like it'd be around here, maybe. You could use Desmos to like zoom in and see for sure. Questions on that? All right, so then table 7, we talked about the cost constraint earlier. And we wrote it down here. Which pairs satisfy the cost constraint, table 7? You can say all of them if there's more than one. They all do? Yeah. Okay. I don't have my key in front of me, so this is my first time viewing this today. So let's see. Class, do you agree with that? Okay. So let's see. You could plug it in, but there's a lot of stuff here. Maybe I don't want to plug it in. Maybe I just want to use my graph here. So this is counting by twos. So 1, 1 would be like here. Is 1, 1 a solution? Okay. 4, 5 now would be like right here. Is that one a solution? All right. 8, 3 would be, looks like right here. Is that a solution? Okay. And then 10, 1 would be like right here. Is that one a solution? So it looks like it. Let me just double check on my keys. The only iffy one was like the 8, 3. I can't really tell where exactly 8, 3 is. It says that 8, 3 is not. So let's double check that. So the ones that you have to estimate, like 8, 3, I told you that one was kind of close. I couldn't really tell. So let's actually see. So type in your inequality. If you need a special symbol, they're down here. And the point that we're trying to verify is 8, 3. So that one, let's see. Is it on the line or shaded area? Okay. And that's fine. The graph they gave you, it was pretty close. But how else could you check without even graphing, class? Good. You could plug in that coordinate, 8 for the x, 3 for the y, and see, is it less than or equal to 110? Let's even do that right now. Since I have Desmos up, I could even do it that way. 9 times 8 plus 13 times y is 111. It's just a little bit greater, and it should be less than. Does that make sense? Okay. That one was a close one, so that's why I was like, I need to check. Now, listen, that meets each constraint individually. Now we're going to examine together. So we could talk about number 5. Explain why 2, 2 satisfies the cost constraint, which is this one. All right, explain why 2, 2 satisfies the cost constraint, but not the length constraint. Maybe share that with each other in your groups. There's lots of ways you can phrase it. So 8, can you tell me why 2, 2 satisfies the cost constraint, but not the length constraint?
The cost 2, 2 is in the shaded area.
Perfect. And is it in the shaded area for the length constraint?
No.
It's not. So that's one way you could explain it. It's in the shaded area of one, but not the other. Another way you could explain it could be when you plug into 2, that's not greater or equal to 9.5. But when you plug it into this one, it will be less than or equal to 1 or to 110. Everyone phrase that, up to you. Now, for number 6, so table 1. What's a pair of numbers that satisfies both constraints? Alright, so let's see. So 10-1, we already said satisfies the cost constraint. Let's see if it satisfies the other one. And yeah, it's in the shaded area. So good. Any others anyone wants to share out? 9 and 1, so let's see. So 9 would be here, 9, 1 would be there, that looks good. And I can't really tell for sure, it looks like it'd be on the line. I know it satisfies the length one when I add it. Did you guys check it with the cost constraint?
Yeah, it's one.
Okay. Let me do that math real quick. 81 plus 13. Is it? Because 9 times 9 is 81. Plus 13 times 1, which is 13. It's 94. Is that, well, it is less than 94. Sorry, I lied. Sorry, my bad. You are right. All right, questions on how to know if it satisfies both. All right, now here's the last important part. And I remember for when we did systems of equations, people lost points on this, and it was like, in my opinion, the easier one. All right, so say we take 10-1. So take the coordinate 10-1, and what does it represent in the situation? Like, what is the 10 representing? Yards of light fabric. All right, and how do you know that? You're right, it is yards of light fabric. Anyone else want to come in? It told us in number 1, X is yards of light fabric, and 10 is in the X position. Also, if you look at the graphs that are provided, it's what's on the X axis. But usually they'll just tell you in the word problem. Or you have to decide it for yourself what you said X was. And then that means the 1 is representing what? Yards of dark fabric. So whatever, and it might tell you, or you might have to establish it yourself, whatever you do establish for X or for Y, once you find a coordinate that meets both, you just interpret it that way. 10 yards of light fabric, 1 yard of dark fabric. Does that make sense? Okay. Now you have a fill in the blank at the bottom. Solutions to systems of inequalities are. So you'll need to fill that in, and I think I'll actually type it out. But solutions to systems of inequalities are pairs of numbers that meet both constraints. So solutions to systems of inequalities are solutions, or we could do pairs of numbers that meet both constraints. So fill that in. Solutions to systems of inequalities are pairs of numbers that meet both constraints. When graphed, they are in the overlapping shaded area. All right, so solutions to systems of inequalities are pairs of numbers that meet both constraints. When graphed, they are in the overlapping shaded area. Because truly for these, you'll have to solve them by graphing. Yes. Just try going back into it. All right, so let me briefly show you. Here's the one for the cost constraint. Let me also add in the one for the length constraint. And now I see both. And they actually also, because they're inequalities, both of them have shading going on. Where exactly is my solution in this picture? Okay, so look at my mouse where it is. Would this be a solution to the system? Yeah. Would this be a solution to the system? Yeah. Would this be? Yeah. So anything that is in here, the overlapping shaded area, so like 10-1, which is what you guys said. All right, in the overlapping shaded area, that's a solution. 9-1. Also in the overlapping shaded area, it's also a solution. If it was on the solid line, that just still has to be covered by the shading of the other one to be a solution. Okay, so questions, comments, concerns on that? All right, I feel like that's what we needed to cover. I know there's more problems on your notes, but I think I'd rather give you time to work on your practice. So please do not waste that time I'm giving you by doing other things. All right. 24 is the lesson we just did. But then there's also a bunch of study guides. You can start getting your binder ready for Thursday. Lots of things you could do.